Okay, so in part one, we talked about identifying and naming the longest carbon chain, and it's the longest continuous carbon chain, which we call the parent chain. What we didn't do is we didn't talk about how to name the substituents, which is what we're going to do now. So naming the constituents is the second thing that we have to do in naming alkanes. And so let me remind you what substituents are. Substituents are these guys in green, right? There's a substituent, there's a substituent, there's a substituent. And by the way, if you're drawing a structure yourself, you can just make the longest continuous carbon chain just be the whole horizontal thing, right? If you're reading someone else's drawing, then you've got to find and verify that the horizontal, like this orange box here, is in fact the longest continuous carbon chain. Right, so, all right, we identify the substituents. Now, if it's a one carbon substituent, like I've got right here, a one carbon substituent, then it's a methyl group. And do you remember that the one carbon chain was called methane, right? And if it's a two carbon substituent, it's an ethyl group, right? And remember we called a two carbon chain ethane, right? So if it's a substituent, it looks like what we're going to be doing is taking the excuse me, the parent name and ending it and just crossing off the ane and making it il, YL. All right, methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, and so on. All right, so that if you get the methane, ethane, propane, then it's going to be a simple step to name the substituents if they're simple straight chain substituents, right? Now, a ring can either be a parent chain or a substituent depending on the number of carbons. So they're not always going to be straight chain substituents, right? So in this case, if I've got a propyl group here on a cyclohexane, I got a propyl group. Well, if the propyl group is cyclic, thank you. If the propyl group is cyclic, we call it cyclopropyl, just like you might imagine, right? So again, all we're doing is just getting rid of the ane and putting it a YL on the end of that, right? You see that? Putting the YL on the end of that. And it turns out, now obviously we do have to memorize the names of these, the names that correspond to the number of carbons. But once you've got that, and you've got the rule and you've practiced it a little bit, it's going to be routine. All right, now, not all of the, what am I doing here? Do I have the right thing? Not all of the, pardon me, looking ahead a little bit. Not all the side chains, not all substituents are going to be simple straight chain substituents, right? So in this case, we've got a branched substituent, which I wouldn't worry about this in the beginning, okay? If this seems overwhelming for you, just first of all, make sure you get the simple straight chain substituents first, okay? Now, if you have a complex branch, here's the rules. Number one, name the longest carbon chain within the substituent, just like you might, right? Just like you're naming the master compound, right? Start with the carbon attached to the carbon chain. So here's 1, 2, 3, 4. So that's a butyl, right? Can you see I've got a butyl? If I didn't have that guy on there, that would just be a butyl, right? So I've got a butyl. And then we name and number the substituent on the side group. So it will be, I've got a methyl group right here on my butyl. There's my butyl. I've got a methyl on the butyl, and it's on the 2 carbon, right? So it's 2-methyl-butyl. You can imagine these syllables are going to build up pretty fast. If you're trying to memorize, a name for this and a name for that, it's going to be impossible. There's just so many variations of it. But if instead you understand where these branches come from, then you'll be set. You'll be ready to go. All right, now, some branched substituents have common names. These will need to be memorized, right? So here's a name of a side group. It's like a little fork coming off there, right? And it's really 1-methyl-ethyl. If you're going to use an IUPAC, can you see there's an ethyl group right there coming off the parent chain? There's an ethyl group, and there's a methyl, okay? But this shows up so often in nature that we have a name for it. It's called isopropyl, all right? So a propyl group has 3 carbons on it. Isopropyl has got also 3, but they're just bonded in different places. Okay, so common names, watch out for them. I mentioned in a previous conversation, you might want to have a sheet of paper somewhere with names on it that simply are arbitrary, things you you wouldn't name them that way unless you were told that this is the way it's always been done. All right, so an isopropyl would definitely put on my list in the beginning. All right, now there are three. So I showed you propyl and isopropyl. We've got the same thing for butyl, which I'm going to show you here. A butyl group that's 4 carbons, 1, 2, 3, 4, right? Is if it's a simple straight chain side group, it's called butyl. If it's bonded to the second carbon, if the parent is bonded to the second carbon, it's called sec-butyl or secondary butyl. Notice that's italicized. If there's a fork at the end, it's called isobutyl, right? You see the fork at the end here? It's kind of like isopropyl, except there's an extra carbon in there. Okay, and if it's like a trident, if it's got 3 carbons coming off of 1, it's called tert-butyl or tertiary butyl. All right, so that's an introduction to naming substituents. We've talked about identifying and naming the longest carbon chain, the longest continuous carbon chain called the parent chain. We've talked about naming substituents, and in the next video, we're going to talk about how to number the substituents and paste everything together.